Thank you very much for an excellent presentation. Pity we don't have more time, but we're already into the break period. But what I was going to suggest is that we could probably cut our lunch time a bit shorter to make up. But that's up to the organizers. I think we will entertain one or two questions, or maybe three, one to each of the presenters. So the floor is now open for any pressing questions, and perhaps you could ask questions of the presenters during our coffee break. But I see Engineer Ray.
Hi, good morning, everyone. Claudia Stewart, Process Engineer, Atlantic. I have a question for Engineer Albada, and that question is based on the design of the reconstruction of the port in Montserrat. Was any fire water monitoring system incorporated in the design? Because in the presentation, there was something mentioned about fuel, and fuel has the potential for, if there's a spark, it could cause an ignition. So I just want to know if a fire water system or fire water monitoring system was incorporated in design. And secondly, there was one design that you all didn't take into account where the water was actually like splashing onto those. I can't remember exactly what it was. But to me, yes. But the thing is that to me, with that design, you could have the potential of like a back flush, or the potential for flooding to occur. So I don't know how that particular item could actually, in terms of the design, how that could be able to be solved, meaning that you wouldn't have the potential then for flooding.
I think I understand what you're referring to there, but let me respond to the first question. You're concerned that the potential for a fire or some type of disaster associated with the fuel vessel. And yes, so it's a very complex project, and I could actually speak for hours upon it. But yeah, we do have a provision for a large fuel tank at the top of what is now the graded gun hill. Just above that, we're going to have a very, very large, I forget the capacity of it, but that fuel tank is there to serve the port as well as the town center. So we have made provision for that. We also have operational restrictions on the berthing and operation and discharge of the fuel vessel. So once the fuel vessel comes into port, essentially, very little other operations can take place. There has to be nobody around, and so on and so forth. The second question is regarding I believe what you're referring to is the overtopping of the hurricane storm waves over the core locks. And what I didn't mention there is that the port was designed from an operational perspective. So it is not a safe harbor necessarily for all types of conditions. And it will be necessary when extreme hurricanes are approaching that the vessels will have to go elsewhere and seek shelter. And the plan is for them to seek shelter in Antigua, which does have more provisions for safe harbor. So the port is designed more from an operational perspective, but yet we have to also ensure that the breakwater doesn't mash up at the first hurricane event. So the breakwater structurally is designed for a hurricane event, but operationally a lot of the vessels will have to leave and seek shelter when a hurricane approaches.
Thank you. We have time for two more questions. Engineer Ray and then Engineer Gibbs.
Yeah, real quick question for Engineer Braden. You went into the...
Morning, Dr. Chin. I have a question for Engineer Christopher Bradley.
Hey, Bill, hold on a minute. It's Engineer Ray, Engineer Gibbs, and then I'll entertain you as the last one.
A question for Engineer Braden. You described briefly the integral connection and the semi-integral connection, and what is the difference of them, and what are the more onerous designs, and why?
The difference between them is the integral connection causes all the load, whether it be seismic load or thermal or shrinkage loading, to go directly into the substructure. That causes the abutment walls and footings to be larger because of the lateral motion of the forces. The moments increase dramatically, and it requires quite a bit more reinforcing and thickness. The semi-integral, since it's floating essentially on bearings, that allows the expansion and contraction due to thermal and shrinkage and creep loads to go into the bearing as opposed to being directly applied to the concrete.
So is one of them easier to design?
The seismic or the semi-integral abutment would be easier to design because it's again, the loading is less in the substructure. Yeah.
Thank you. Engineer Gibbs, and then Engineer Ramarthan.
My question is for Dr.
Use a mic.
The orthopedic surgeon,
Okay.
Dr. Ramroot. It's about Couva Hospital, Dr. Ramroot. There was a position paper published by the Trinidad and Tobago authorities responsible for executing the hospital project in Couva. And I quote from it. I'm quoting from it. I believe that the methodologies outlined in the adopted codes of practice in Trinidad and Tobago, the ASC 705 and IPC 2006, as currently mandated by the Ministry of Works and Infrastructure, Structural Division, using the current PSHA-derived seismic hazard maps, are sufficiently rigorous to be applicable to the safe seismic design of structures in Trinidad and Tobago at the current time. Now, one should remind oneself that the compliance with the quoted standards would not provide a hospital which would be fully functional immediately following a strong earthquake. Now, in 2004, on the day before Mahatma Gandhi's birthday, 1st of October, the PAHO 45th Directing Council had passed a resolution on disaster preparedness and response called Safe Hospitals Initiative. It was signed by the Minister of Health of Trinidad and Tobago. And it dealt with the National Risk Reduction Policy, which stated that all new hospitals should be built to guarantee they remain functional in disaster situations, and that government should implement measures to reinforce existing facilities. It also defined a safe hospital as a health facility whose services remain accessible and functioning at maximum capacity and in the same infrastructure during and immediately following the impact of a natural hazard. Now, clearly, Couva Hospital does not comply with that. Bearing in mind that none of the hospitals in Trinidad and Tobago at the moment can function immediately following a major earthquake as defined by the Ministry of Works and Infrastructure. Why is it that the two new hospitals being designed and built in Trinidad are not complying with this resolution signed by the Minister of Health on the 1st of October 2004?
Well, we will have to have another conference to deal with that question. But I guess everyone here knows the answer. I think it's a rhetorical question. One of the biggest problems we're having in the globe is the interference of politics with science and academia. Now, that's a bigger nut to crack, right? That's one. The second one I alluded to in my talk, which is if you listen to it very carefully, it had a lot of very important statements coming out from that without being too abrasive. The second very important one is the ability of the scientists to present their proposals, right, in such a way that it is easily understood in a business sense. And I had that problem, for example, I was involved with PAHO, right, during the ICC World Cup Cricket Tournament, right, as well as Summit of Americas, in developing and working with the experts that came in, and I was the medical chief of staff of the San Fernando Hospital, whilst we were dealing with the elements of the Safe Hospital Index. As a matter of fact, even now, at the regional level with SEDIMA and PAHO, even at the regional level in terms of South America and CEPRENDAC in Central America, I am also working with the experts from PAHO and Geneva, UNISDR, in also making sure that safe hospitals exist throughout the region. The problem is that you have to understand that what we had in the past is what scientists, right, they can present an excellent paper. The problem now is to convince the executive arm of government using things like business proposals, cost-benefit analysis, and all of the tools of business to make these people understand what you are trying to say. We even have that in health. So that's the second problem we're having. The third problem I mentioned is governments, and governments change, and the agenda of governments change. And that has caused a serious problem in if another government comes in Montserrat in the next, 6 months or 8 months, they might have a different understanding of what they might want with that harbor. And that is a problem we all have, because each government has an agenda. The fourth and most important thing is legislation. You see, although the Minister of Health signed that many years ago, that was probably a minister of another government, right? What we have now is a policy decision to build a hospital no matter what, right? And that has caused a problem, right? The problem, how is it? We cannot approach that with one single solution. That hospital is being built, yes? The problem now is that we now have to deal with the consequences of a hospital, like many of the malls in Japan, being built on fault lines, right? So we now have to improve our post-disaster function in terms of non-structural measures, which, as I told you, have a very, very important part to play in addition to structural measures, because I mentioned that you cannot build for some of the black swan disasters that are coming. We have not been able to build, for example, for landslides or tsunamis. And therefore, we have to understand that when we're dealing with those risks, we have to have non-structural measures. All I'm saying is, if you look at the overall risks of the country, if you go to buildings that are non-engineered, we have a greater problem than a hospital that is going to house, if you have good structural and non-structural measures, even as we build that. And I went to Geneva recently, and we saw many of the expert structural engineers building malls, right, just very close to fault lines. And they're designing it that in ways that I can't predict, or they can't predict about what the black swan will bring. So if we go on in life and think about there's something that's going to destroy this entire building no matter what, I think it's something that it's a very big, as I say, it takes a whole day to answer that question, right? Because we can't solve it here. What we can do, however, is what the science is recommending. The science is recommended very simple. Engineers, I'm telling you, you have 3 things that you have to do to answer that question. 1, change in professional practice. Re-look at what you're doing, take your science and convert it into easy products that even the fellow in the house will understand. Use the systems that we are putting in place based on disasters all over the world, get involved in core, take the engineer and bring him to the home. And I don't have to tell you that, I have to read it. Get to the schools. The engineers of the associations need to go into the schools, and for permanent change, for the better, the education program starts in the primary school. In other words, then we need you to go with us to the schools, because we need to look at it over many years. I was in Lisbon about 6 months ago, and when I went into Lisbon, the tour guide who took us around was looking at the buildings, and he was saying, when we have the disaster earthquake, this is a good building because the people can go back after. Now, this is a tour guide in Lisbon. That is a culture, right, that has evolved from the last earthquake. So your answer, we haven't even gotten the culture in our people in Trinidad and Tobago, because people themselves building their non-engineered houses, right, are building them wrong. People who are building the engineered houses, right, are getting approvals from people who are supposed to give them the right approval, but if they get a few dollars, they say, go ahead, build what you want. Now, this is a culture that has to change. And it's not just the hospital. The hospital is just the pinnacle of a bigger problem, if you know what I mean. So if you look at us without even a legislative authority, this is what we're trying to do. We're trying to achieve legislative authority. Not to go back and inspect all the plans in the country, you know. What I'm trying to tell you, that was the other lesson. We don't have to coordinate activities because we don't have the legal to, that's what I'm showing you. We don't have the legislation. If I had the legislation, it still doesn't mean that I wanted to see the plans of the hospital at Couva. I don't want to see that. I want the people who're supposed to see it and to do what they know best. Because I don't want to go and have another system where I have to go back and look at a plan. That's another set of bureaucracy, which we don't. And that is what the world is saying about disaster risk reduction. Every single person here can do what they want about all what they want. But you have to understand that one of the things about disaster risk reduction is about what's going to happen to us as human beings when we become old and walking with our sticks in the next 100 years. That is where we're going to, because it's all about development. And people forget that. And Trinidad and Tobago forget most of that because we have never really been hit with the degree of impact. So therefore, that's one of my other challenges. If the population themselves drink down on West Shore and wherever you drink down in the avenue before hurricane is coming, yes, then how can we expect the population to lobby against a hospital like that? I think this is what we need to do. We need to build the platforms. The second thing that we have to look at, again, is answering your question about earthquakes. Yes, finally. The last thing is, the third, I mentioned too, the third thing that I want engineers to do is retrofit. The problem about retrofitting, if you look at the overall stock, right? Yes, we have the hospital. These are new buildings. But we want you to get involved in trying to look at our retrofitting issues, because that is probably the biggest problem we have and the best cost-effective one in terms of looking forward. To answering questions like that, it takes a holistic view of all that we're doing. I'm sorry, I can't give you the answer, but I hope that I have been able to give you an overview of our challenges.
Thank you. Thank you, Dr. Ramrup. Thank you, and we'll now break for coffee, and we will resume at